Good morning to one and all. I am Spandana from ECE department. Today's subject is physics. Today's topic is de Broglie hypotenuse. Introduction. A French physicist who introduced the revolutionary concept of wave-particle duality for matter. Who was Louis de Broglie? Won the Nobel Prize in Physics in 1929 for his groundbreaking work. What is the de Broglie hypotenuse? Statement. De Broglie proposed that all matter exhibits both particle-like and wave-like properties. Key idea. Just as light can behave as both a particle and a wave, particles like electrons can also have a wave-like properties. The de Broglie hypotenuse proposes that all matter exhibits wave-like properties, extending wave-particle duality beyond light to include electrons and other particles. It quantifies this wave behavior with the equation where lambda is the wavelength and h is the Planck constant and p is the momentum. Wave particle duality. The theorem that particles of wave matter, such as electrons, can display characteristics of both waves and particles. Amplification. This concept leads to the development of quantum mechanics and changed our understanding of the physics world. De Broglie wavelength formula. De Broglie hypotenuse that a particle with momentum has a wavelength given by lambda is equals to h by p is equals to h by mv, where lambda is the wavelength of the particle and h is the Planck constant. Planck constant value is a 6.626 into 10 to the power of minus 34 joules by second. P is the momentum of particle. P is equals to mv, where m is the mass and v is the velocity. Explanation of de Broglie wavelength and interpretation. The wavelength of a particle is inversely proportional to its momentum. Implications. For larger objects like a baseball is too small to be observed. For subatomic particles like electrons is significant and wave-like observer can be observed. Experimental evidence. Electron diffraction experiment, the deviation German experiment, confirmed that electrons can produce diffraction patterns supporting de Broglie's hypotenuse. Significance provided experimental evidence that particles can exhibit wave-like properties. Applications of the de Broglie's hypotenuse and quantum mechanics. Basic for the Schrödinger wave equation and the developments of quantum mechanics. Electron microscopy utilizes the wave nature of electrons to achieve high resolution imaging. Modern physics foundational to understanding atomic and subatomic phenomena. Impact of de Broglie hypotenuse revolutionary contribution alerted classical components of matter and energy, bridged the gap between classical and quantum physics, extended amplification. The wave particle duality concept applies to all particles from electrons to larger molecules. Conclusion Summary De Broglie hypothesis suggests that matter has wave-like properties. This idea has been confirmed through experiment as significant implications in quantum mechanics and technology. Final touch De Broglie's work laid the foundation for a deeper understanding of the dual nature of the matter and energy. And thank you.